So we multiply this negative 1 across, and this becomes, so we flip the sign, and then this becomes negative 4. So we have it now in the standard form. Let's find the x-intercept point, and then we'll find the y-intercept point. So remember, the x-intercept point's where it crosses the x-axis, and this is when y is 0. So we're going to let y be 0. So 3x minus 0, right, is greater than negative 4. So we solve for x in this problem, and we end up with not a nice number. Now, we could just write an equal sign right here, if we wanted to, because we're just trying to find where it crosses the x-axis. So I'm just going to do that. So don't be confused. I'm just writing an equal sign here, okay? So this becomes negative 4/3. Right, we multiply both sides by 1/3, and we get negative 4/3. So that's, we'll say that's right here. Negative 4/3. So we know that it crosses the x-axis right here. Okay. So now let's find where it crosses the y-axis. That's when x is 0. So this is going to be the y-intercept. Of course, I'm not writing the point here, but the point is going to be negative 4/3 0. Okay, that's your point right here, negative 4/3 0. The y-intercept, so that's when x is 0, so 3 times 0 minus y, and you don't mind, I'm just going to write an equal sign here, so don't get confused. We're just trying to find where it crosses the y-axis, alright? So we end up with negative y is equal to negative 4, but we multiply both sides by negative 1, and so we get y is equal to 4. So the point here is going to be 0, 4. So 0, 4, and we'll say that this up here is at 4, and so this is 0, 4 right up here. So we're looking at what are we doing here? We're looking at a line that passes through these 2 points, so let's go ahead and draw that line, and I'll just draw it green. How's that? So we're going to attempt to cross this. Okay, so here's our line. I made a mistake. Look out, there's not an equal sign right here. You notice this? No equal. So this should be a dotted line right here. This should be a dotted line. Okay, so let's go back and draw a dotted line. Whoops, I didn't mean to do that. It's okay. Alright, so we have a dotted line here, which means that we don't include, right? We don't include the line itself. Alright. Okay, question is now, which side of this dotted line is shaded? Well, we look at our standard form, right? And we notice our inequality is pointing to the right. So I just pick a point here, and we're pointing to the right. Put an arrow over here, so pointing to the right. So that means that every single point to the right of the dotted line, every single ordered pair, right, is a solution to our inequality right here. And we can always choose 0, 0 to test this. Right, we plug 0 in for x, we get 3 times 0, 0, minus 0, and therefore 0 is greater than negative 4. Okay, so I always choose the origin because it's a whole lot easier to choose. Right. So we shade everything to the right of our dotted line. Okay. All right, let's look at something a little different, and that is what happens if we were to graph two shaded regions. All right.